This is going to be a rather short video. I will just continue reviewing my code base before it's time to actually test these two boards on a real machine. But first I want to review the code base, and I want to make sure that we don't get any unnecessary surprises. Like, of course, there may be surprises when we do the testing. There may be things we haven't thought about, but I still want to review the code base and just make sure that anything that I see that I know is wrong is not going to be there when the firmware is actually tested on a real machine. So I'm just going to come up with a title for this video. And this video could be continuing on with the code review. If you haven't joined the Discord channel already, then please do so. The link is supplied in the video description. And actually, it could be that the link is not working. I'm going to check that. I had that situation before where Discord link wasn't actually working, which leads me to believe that maybe Discord links work for only a day, and then you have to get a new link or something, or maybe I should get a link that is permanent, but I will check if the link in the video description actually works. And this link obviously doesn't work. So something is weird here. Let's see. Maybe it works if I paste it here in Firefox. Yeah. So maybe invites work only for a single user or something. I'll have to solve this. This is really annoying. I need to get some kind of permanent link, or get a link for the channel or something else. I don't know. Let's see. Where is the channel URL? Maybe I can share the channel URL directly. What if I do like this? Sorry for this video being so boring. I haven't started the review yet. Okay, maybe having this direct channel link is actually going to work better. So let me just update the video description. So if you try the new link now, maybe you're able to join. Anyway, continuing on with the code review. And I'm going to bring up the list of all methods which I generated before, which is actually generated by the script here. Let me just exit the terminal. And this script generates the list of all methods using the output of nm command, and then it filters out things that I don't want to review. So these things are FreeRTOS code, my generated code, which is responsible for registering device drivers and registering device classes, and also finding devices based on class. Things that are not present in my code base, which is going to be ending with a question mark instead of line number. Anything that goes into startup code of STM32, I'm not interested in reviewing that right now. Anything that goes into standard peripheral library either. And anything that goes into libfdt, I don't want to review that right now. And by the way, libfdt is only responsible, it's only running during the initialization phase. So if the initialization phase completes successfully, we know that that part will always work. And anything that, any methods that end in KO, which is actually constructors for device drivers, which get called automatically during startup of the executable. So those things are either generated automatically or part of code that I did not write. So I don't want to spend time reviewing them right now. I'm going to only focus on the code that I actually written. So let me open the file that is called Flying Bergman Review. Actually, it's going to be review CSV. And this file contains all the methods that I want to review. This is 259 methods, so this is doable. It's not that many. And I will go through each method in turn, and then I will, let's see, somebody's calling me. Suspected spam. So whoever is calling me, if you're listening to the live stream, you are actually suspected spam. So you're welcome to call back or email me instead, or I will call you back after I'm done with the stream. So let's have a look here. Range. So I'm going to start with lower level stuff, so things like device drivers. And I'm going to leave the methods that are part of the application for later, because I want to review all the lower level stuff first. And in case I need to change any of the lower level stuff, then I can update the application code accordingly when it's time to review the application code. So let's see here. We could go to... I'm actually going to copy this just to... do I have to do this? I'm going to copy from the raw. I think that just to make sure that we start with the latest file. So copy this to, let's see. So this is actually even fewer methods, which is good. Okay. Great. And all of them are now sorted by, or actually this was not sorted. So this is actually something that I could even do here. Let's see. Sort K 1, 2, 3, 4, 5 K5. And let's build this. Like this. And now I'll just copy this again and see if we get, yeah, now we have a better file, which is easier to read, which is sorted by the by the file name where the method is actually placed. So FreeRTOS stuff, yeah, I could review that as well. Okay, cool. So let's leave the main for now, and we can start with hard-fault handler. So it is in the fault, and this can be cleaned up. I don't need this code anymore. This code basically gets all of the registers, including the program counter, in order to see where the hard fault actually happened, which is very useful. And once we get to this point, the system is halted, so I just loop there forever. And then I can connect with GDB to this executable and read out the program counter to see where the fault has occurred. So this goes away, this goes away. Application switch hook. This one is, let's see, this one's actually the main. So I can go G and large F, no? Oh, let's save this file. This is basically called whenever we switch a task. This could be useful for things like keeping track of how many task switches we do. But for now, I will just leave it as it is. Let's go back. Init is also here. Let's see. Come on. This is just the init process, which probes all of the device drivers. It is important to probe device drivers from a thread because you want to be able to sleep and just basically use any of the thread functions, just like from any other process. So that's why this is actually a process instead of being all done in main. And then we have the stack size of the init thread. It's kind of hard coded at the moment. And then we have all of these methods. They are never used. They're just here to warn about their usage. So all of this stuff is currently not implemented. Let's delete this. This will be called if any libc functions that use this callbacks are called from the application code. They will not work properly. And this actually includes printf. This will actually also return -1. All of them will return -1. So we'll return 0. So we don't want to use this. I checked that even using just opening a file takes 2 kilobytes of RAM. like on a chip that has a limited amount of RAM, using the file functions is really not the best way to do it. Let's see. God damn it. Implemented. There we go. And this is going to be red as well. Print error. Output not implemented, read not implemented. I can basically mark all of these as done. Then we have the LP55231. Let's see. And this will be, let's see, this is the LED driver, right? So this, first of all, this is going to be printing out errors. And then and then this one, let's see exactly what delay this needs to have. So let's see. LED error detection could be useful. So where is let's see here. So reset. 500 microseconds startup delay. So that's good to know. This needs to be updated in the code. And what I want to do is actually, let's see. I want to toggle the end pin. And let's see here. So let's try to reset the chip first. Let's see. And I'm not really sure exactly if this chip behaves well on the I2C bus when it's disabled. Nice to make sure. It would be nice if it had some reset pin, like an external reset pin. But it doesn't seem to have one. Okay, so we should be able to issue a reset before enabling the chip. And then after reset, what do we have after that? So this should be, let's do like this. Let's wait 1 millisecond. After toggling both the enable pin and also the control register enable. So after reset, both of them, or actually the control register should be low. And here I just make sure that the enable pin is high to enable the chip. Then I write the enable bit, so now it should go through the startup sequence. And then write the MISC register value 09. What exactly does that mean? Okay, 09. So that will be forced internal clock, and let's see, forced to bypass mode. Wait a minute, I want to check the actual, let's see here. Where is this MISC register here? So clock source, and then, right. So I'm running in forced bypass mode. Okay, which is fine. I have been using that and it worked. So I'll use that here as well. Yeah, I'll need to create defines for other bits as well, if I'm to make this flexible enough. Okay, so clock set to internal, then we sleep 50 microseconds. I'm not sure if that's really necessary. Remove that. So actually, all of this can be initialized before the chip is started. Let's put this here. And then we enable the chip, and it goes through the startup sequence. So this should be this feels reasonable. And then enable the chip here. Okay, great. And then it will also be interesting to do the LED test control, to actually run the LED test. Okay. So many registers. 3A status. Oh, cool. We could actually check that the startup sequence is done. Alright, so this will have to go through all of the diodes and detect which diode is connected. And I think, I wonder what it actually measures. Does it measure the current? Okay. Okay. This is very good. This will give me an idea of which diodes are connected, so I could actually print that out. And I'll just have to go over all the diodes and do the measurement for each diode. But now I have to stop this video, so thanks for watching, and I hope you learned something.